Okay, so in this video we're going to look at applications of quadratic functions. Here's a handout that I have for you. On this handout is a bunch of problems. Problem 1, we'll look at applications of quadratic functions here. Problem 1, a rock is thrown directly upward from ground level with an initial velocity of 90 feet per second. Its height h in feet after t seconds is given by h of t equals 90t minus 16t squared. Part A, how high is the rock after 1.5 seconds? And then part B, determine the time at which the rock reaches its maximum height, and then find the maximum height of the rock in feet. Okay, so part A, I'm given the function h of t, and I need to determine the height of the rock after 1.5 seconds. So if I start typing in here, 90 times 1.5 minus 16, I get 99 feet. Okay. So part B, determine the time at which the rock reaches its maximum height, then find the maximum height of the rock in feet. Part B, okay, so if we take a look at the graph of f, the graph is going to be a function facing down, because of the negative a value. Negative b over 2a, h of negative b over 2a is going to give me the maximum height of the rock. B is negative 90, negative b, divided by 2a. 2 times negative 16 is negative 32. And then I want h of that. Okay, negative 90 over 32 gives me 2.8125. That's an exact. And then h of 2.8125 gives me 126.5625. I plug that in there. So I guess the time to the max height is in terms of t. The h value, or the t value, is 2.8125 seconds, and the max height of the rock is 126.5625 feet. Okay, and those are both exact. Problem 5 says that a farmer with 600 feet of fencing wants to enclose a rectangular plot that borders on a river. Suppose that x represents the length of each of the 3 parallel pieces of fencing. See the figure. What is the length of the remaining piece of fencing in terms of x? Okay. Part B, determine the function a that represents the total area of the enclosed region, given any restrictions on x. Then part C, if the farmer does not fence along the side of the river, what is the maximum area that can be enclosed? Okay. Well, part A, and by the way, here's our river that we've got, and we've got x feet. I'll call the remaining distance y feet. And so part A, what is the length of the remaining piece of fencing in terms of x? Well, I got x plus x plus x, that's 3x plus y is plus y equals 600. So y would equal 600 minus 3x feet. Okay. Part B, and again, I'm not fencing along the river there. Part B, A of x is going to represent the total area of the rectangle. The rectangle has a width of x and a length of y, so x times y. And I know y is in terms of x. It's 600 minus 3x. So where I see y, I'll replace that with 600 minus 3x. X times y, or x times 600 minus 3x, gives me negative 3x squared plus 600x. Okay. Give any restrictions on x? Well, I know that x has to be positive. If x is 0, then I have y 600 feet laying along the side of the river. I'm not actually building a rectangle. So I know x has to be positive. I also know that y has to be positive. Okay, now y is equal to 600 minus 3x. So that has to be greater than 0 also. 600 is greater than 3x divided by 3, so x is less than 200 feet. Okay, the domain of A, therefore, is the set of all x such that x is greater than 0 and at the same time less than 200. See, if x is 200, then I've got 200, 200, 200. I've already maxed out my amount of feet for the enclosed area, all 600 feet. And I don't have anything for y then. Okay. Part C says if the farmer does not fence along the side of the river, which is what we know early on in the problem here, what is the maximum area that can be enclosed? Well, the area is a parabola, and this parabola is facing down, okay, with the negative a value. So basically, I need to find the highest point on the parabola. Well, that's an exercise in finding the vertex. Negative b over 2a, and then a of negative b over 2a. Negative b is negative 600 divided by 2a. 2 times negative 3 is negative 6. Negative 600 over negative 6 is 100. And then a of 100. Here's a. A of 100. Okay, so 600 times 100 gives me 60,000. Okay, minus 30,000 would be 30,000. So and that's the maximum area. So the maximum area that they're looking for is 30,000 square feet. Now, they're not asking for it here, but the dimensions of the rectangle that would produce 30,000 square feet would be when x is 100. Okay, and 100 plus 100 plus 100 is 300. 600 minus 300 is 300. So y would have to be 300 feet. Okay. And I guess maybe kind of like how I drew this is about what I want. 100 feet by 300 feet. Okay. Problem 9. Let's see here. Problem 9. A company would produce radios. The average cost to produce each radio in dollars is given by the function 0.009x squared minus 0.432x plus 9.3, where x is the number of radios produced in thousands. Okay, part A, for what number of radios is the average cost per radio minimized? And then part B, what is the minimum cost per radio that is possible? Okay. Well, I've got the function written. Okay, now a key thing in both parts is the word minimized. Okay, so in other words, we have a parabola that is got a positive a value, so it opens up, and in other words, I want to find the minimum point on the parabola. Well, that's the vertex. Okay, and by the way, notice how every single one of these problems, at some point, you're going to find the vertex. Okay, so keep that in mind for when you do this sheet here. Basically, every problem is going to be where you find the vertex. So the vertex, negative b over 2a, and then f of negative b over 2a. Negative b is 0.432. 2a is 0.018. 0.432 divided by 0.08 is 24, and then I want f of 24. Okay, f of 24, when I plug in 24, gives me 4.116, and that's an exact. Okay, so part A in this, for what number of radios is the average cost per radio minimized? Well, the company would have to make 24,000 radios. Okay, if they make too many, then the cost is being put into the radios, and the cost is they're not selling enough. And if they're making too few, well, they could be selling more. Okay. In the part B, what is the minimum cost per radio that is possible? Okay, the company would want to charge $4.12, I guess. You round like you normally would there, per radio. Okay, so this is basically an exercise in finding the vertex. Once we find the vertex, we're done. Okay, so the homework is the quadratic function applications worksheet. That's this worksheet here, and I've got all the answers there on the page. And okay, so have a look at that for me, and we got one more section left in chapter 3 here.